Okay, so I don't think that we need a huge introduction now, but Sébastien will take a stage today as well as a speaker. His presentation is called Understanding the Performance Characteristics of Orchard Core. Why is Orchard Core slow when it's slow, and why it's fast when it's fast, and how you can figure it all out. You will know all about it now.
First question is whoever came with this description is interesting.
You.
Why is Orchard slow and why is it's not slow? There is no reason why it's slow. There is no slowness in Orchard. It's just fastness of everything. So it's fast everywhere. And then Sébastien doesn't need any introduction, but I think I will do an introduction today because apparently I get so many questions about who are you that I will do that today. And if I can't finish everything, there is the next part this afternoon. I don't know when and where and how, but apparently there will be a next part. That's how it works. And so Sébastien Ros, I work at Microsoft, and I've been working at Microsoft for 15 years. I started 15 years ago to work at Microsoft for Orchard 1. So I joined Microsoft to work on Orchard 1. And I've been working on Orchard since then, but it hasn't been my main focus from the beginning. So I started 5 years full on 100% on Orchard 1. Then I joined Azure, where I stopped working on Orchard, just drove the meetings for like 3-4 years. And then I went back on the ASP.NET team to work on Orchard Core. The goal was to make Orchard work on .NET Core, which was still a beta, and the goal was to see if .NET Core could be used to make something like Orchard, and if it was not, then there was an issue with .NET Core, so that's why I joined back to work on Orchard Core, which I did my full time as a Microsoft employee for like 3 or 4 years, and then management changing and priorities at Microsoft and goals changing at Microsoft and in my division, then I was asked to not work as much on Orchard Core, so I became like a side task until it became a no task. So today what I'm doing for Orchard is okayed by my manager's chain, meaning they are okay with me spending the time I spent today on Orchard Core, but that's about it. If I stop, they will be fine with that. So Microsoft and the ASP.NET or the dev division is not involved at all in Orchard Core, but what I'm doing, I'm still doing it, and everyone is happy with that. If you want me to work 100% on that, just pay me as much as Microsoft pays me, and I will do that. But good luck, okay? Which is a good thing, okay? So I'm thankful for that. So for whoever asks how much I work on Orchard and Microsoft, that's the official answer, and I think that's the fine answer. Did I wish I would work all my time on Orchard Core, like every one of you? Yes. Okay, but that's not the case. And so Microsoft is not supporting the product at all, okay? And I don't think they're supporting any other CMS, but SharePoint maybe, if you can say it is a CMS. And yeah. Yes, if you have questions about it, maybe you can send it, because I got so many questions about it the last 24 hours. Good. Then, what do I do if I don't do Orchard Core? I do performance. I make things slow, Orchard, and fast, ASP.NET. I do performance. I also work on Aspire, and every year it changes, but my side duty is also used to be like my main duty, performance benchmarking in the ASP.NET team. Now it's more Aspire, and I also still maintain the performance infrastructure at Microsoft, well, in ASP.NET team. So that's what I do. Performance. What is performance? So for a website, we care about all these things. Requests per second. How many requests your server can handle when it's at peak usage, and also at steady state usage. Like if you have, right, what I mean by peak and a steady state, I mean how many can the server support, but then when you have a steady state usage, which is the thing you want, what are the other characteristics of performance? Mainly the latency, like how fast can the page be served, and we look at multiple values, like the average value, okay, like you take the average of all the requests during a period of time, And then the 50th percentile, the 99th percentile, maybe you care about the 99.999th percentile, meaning in this percent of request, what was the slowest of the request. Okay. Sometimes your service will need to provide, 10 milliseconds for the 99.9999 percentile, because you really want all your requests to be less than 10 milliseconds. You don't care about 0.1 millisecond or 5 milliseconds. It has to be less than 10 milliseconds. There are services that require that. The startup time, like how long it takes for your web app to start up, to be ready to accept responses. Okay. And then the first request time, how long it takes to serve the first request. So if you take the two of them, the startup plus the first request, you have your time to availability or something like that, like time to first request, let's say. And it matters in case your service is on Kubernetes and needs to start quite often, be taken down, start a new node, and how long it will take for the node to be ready. The first request is important because it's usually when you initialize all your system, you load your content type definitions, you load your caches, your services, everything that is lazily initialized. And that so you could improve your startup time by cheating and moving everything on the first time request. Okay, on first request time. Or the opposite, remove something from the first request time and put it on the startup. It depends on what you care about. But the sum of the two is the important metric. We will care about memory usage because you have to pay for a machine which has a specific amount of memory. And if you do some high density hosting, .NET or something like that, then you will probably be limited by the memory and not the CPU. Because if a site is up but is used like one request every 2 minutes, which is totally possible on a small websites, it will still take the same amount of memory, let's say, okay? As if you had like 100 requests per second or 1,000 requests per second. Not its peak usage, but a slow amount of requests will be the same cost in memory as an average amount of requests. And this can grow very fast if you have lots of tenants in Orchard, or if you have a website that loads data, which is huge, and it doesn't depend on the number of requests. So this is something we need to take care about. There is the peak and the steady state. Peak and steady state because memory usage will also vary over time. When you start up, maybe you will have to load lots of data and then manage it and compact it in some way and convert it in some other data store. And this will take a lot of memory. And then over time, it will be reduced because on steady state usage, you don't need all this memory again. So the peak and the steady state are two important values. Size on disk, if you do IoT, maybe, if you don't have a big hard disk, or if you need to transfer data when you deploy a lot. So that might be an important value to look at. The build time, because of your CI pipeline or your dev loop matters. Like, do we want to spend 2 minutes every time we build Orchard Core, or do we want to spend 2 seconds? It's better if it's 2 seconds, right? And if it's 5 minutes, then it's useless because I don't want to wait 5 minutes before I can test a change. So this is what we call a dev loop, how long it takes to see a change for real. And hardware requirements, like what do I need to run something? Do I need 100 megabytes? Do I need 1 gigabyte? It will change a lot for your deployments. Do I need one CPU? Do I need a super, ARM chip with AI chips and whatever? No. So then how to improve performance? Or at least to manage it, 3 different concepts: observe, verify, improve. I made that up. You can't find it on Google. I made it. That's my own knowledge here. So you can take it. It's for free. Observe, continuous benchmarking. So you need to continuously check your benchmarks to see if your app is slowing down or getting faster. Okay, it can be fine to slow down if you know that you made a change that will slow down, or you are okay to pay for the price for the change, okay? We need this feature, it will be slower, but it's a feature, okay? You can't add more and get faster. Or the goal was really to add something to get faster, but if you add more features, it can just be slower. So it's okay to be slower, you just have to know why it's slower, and for that you need to observe the changes continuously. So there is no surprise, or at least you can expect surprises and you can react to that. It should not be a surprise in a year. Verify. So whenever you do a change, you should check that it doesn't impact performance. Even if you think it won't impact performance, it will impact performance. It's usually when you think it won't, that, oh, we didn't think about it. You just know when you know, no? So verify. And it means when you do a PR on any project, you should think about the code and will it make the thing slower, faster? Can I do something that it doesn't make it slow? Can I check the performance before I merge the PR instead of relying on the observe, which means continuous benchmarking? If it's too hard to verify a PR and you merge it, then you will observe the next days the performance just to see if it degraded or just didn't degrade. And improve, which is a bunch of work that you can do preemptively on purpose to make things better, okay? Faster, smaller, whatever. Example of why continuous benchmarking is important. So this is an issue I filed on the HA proxy project. You know HA proxy? Who knows HA proxy? It's the best proxy. Just one, you are all fired. Zoltan? No. You're fired too. Okay. HA proxy, it's one of the best, like 2 or 3 proxies, web proxies. You do web, right? We agree. You do work in the web. You do websites. Okay. So next year you don't go to the Old Shortcut conference. You go to the HA proxy conference. Okay. You will learn some things, I'm sure. Oh, I'm so disappointed. So HA proxy is a proxy. Do you know what a proxy is? You know because you use HA proxy, right?
Well, I use it, but
well, you know what it is. What's the proxy? A web proxy. Benedek Milan, Gabor, no? What? A proxy. So it's something that relays an HTTP request to another server. It's a web server. It takes a request. And you know, I've talked about it like so many times to improve perf and no? So it's a web server. It takes a request. That's what he wants with it. Send it to another server, gets the response, send it back to the client. And in between, you will say, what can I do with the request? I can cache it, I can change the headers to send it to somewhere else, or I can say, oh, let's send it to this one, or then this one, to do some reverse proxying. And then, let's add back a header just to hide it was IIS, and let's say it's Apache, and send it to the client, so they think it's Apache, but it's actually IIS. You can do some things like this. That's what a web proxy is. And HA proxy is one of the main famous one. So what is the most famous one? Nginx. You know Nginx? Who knows Nginx? Okay, so HA proxy is like Nginx. That makes sense? Okay. But Nginx is known as the fastest one. HA proxy is almost as fast as Nginx. It's freer, it's more open source than Nginx. Nginx has a commercial license also. So I found an issue there because in the ASP.NET team, we do have some continuous benchmarking on HA proxy just to see how do they do, because in the ASP.NET team we have a proxy called YARP. Have you heard about YARP? Yes, Ipke. So YARP, HA proxy is like YARP. Now you understand what HA proxy is? Okay, good. So we have YARP. So we want to continuously benchmark the YARP engine. And so we also look at the other proxies just to see how they behave and if YARP is as fast or slower or faster than the other. So we look at HA proxy and Nginx. And by looking at that continuously, we saw one day that at this date, HA proxy went from 200 million requests per second on the load we are sending to 500,000 requests per second. Okay? Wow, what happened? And we saw that because it was on the charts and we do continuous benchmarking. And I went on the website and I found an issue and I told them there was a template and they were happy with that. I just said, I found a perf improvement. And they were like, well, continuous benchmarking is awesome, good job, yeah. I would like a link to that because what? They don't have continuous benchmarking. They had no idea that HA proxy went from 200 to 500. They didn't know. They did some changes. They expected it to be better, but they had no idea. So this is one of the main contributors. And another main contributors, yes, the recent updates are encouraging, blah, blah. We've been working on that, but we didn't know. So thank you. Good. So this is the RPS, request per second, and this is the latency. Even the latency went down. It's usually at peak, it's correlated. The request per second will increase if the latency decreases, and the opposite. Okay. So yeah, example of continuous benchmarking. You should have that on your website because maybe you don't know, but someone pushed a change and it made it super slow. You didn't know. So what's important also is reproducibility. I had to Google this one for sure because I was not sure what syllables were in between of whatever. Virtual versus physical. So when you do a benchmark, you could use VMs or you could use physical machines. The issue with VMs is that when you start a new VM, you are not sure if you are getting the same physical machine or if you are getting a smaller one, a bigger one. It can change. So if you do benchmarks on VMs, then you might have different numbers and you don't know if it's your app or if it's the VM itself. And also there will be so much noise that you won't be able to find the differences. So should we benchmark on GitHub Workers, on cloud VMs? Probably not. If this is all you have, you can do it. But maybe do on the same instance, do a benchmark before after, not a benchmark over days, because the charts for continuous benchmarking will not work. Noisy neighbor, when you use shared hosting, maybe there is someone else that is running something on the same machine in a different proc, and that will impact the memory. There will be, you don't never know. The disk changes, so it's better to have a machine that is dedicated to that. Should you do benchmarks on your own laptop when Visual Studio and Outlook and Teams are running? Probably not, because when you have a number and another one, you're like, crap, I received an email in the between, or I have the Teams message. Maybe change my number, so you will run it again and again and again. If you are not confident with the numbers you get, the benchmark is useless. So what's the point of doing it? And then when you do benchmarks for reproducibility is important, you need to be able to reproduce it. So you need to keep all the binaries you used before, all the commit chars, because the code source might have changed, the dependencies might have changed, the arguments of your runs might have changed. So this is important for reproducibility. Another example. So this is same thing, continuous benchmarking over multiple days, like months. You see February, April. And this is the request per second of a simple JSON result on a web app. And request per second, this is 30, is it request per second? This is latency, and this is request per second. So I don't know why it is 30. It should be like maybe 30,000, I don't know. Well, from 30 to 50, and then back, and you see super stable. Okay, that's a hysteresis effect. And like 3 weeks every time, almost. And I try to reproduce it. I go on the machine, I take exactly the same binaries, everything the same, okay? Because I'm a pro, I know everything. And I run it, and I still have that. And I restart the machine, and I have one run like this, and then it starts again. If I do it locally, okay? But this machine here was restarted every days, I think. Yes, this machine was restarted every day, and this was a Linux machine. And on Windows, if I restarted the machine, I will have a few runs that will be fine, and then again it will go back. I don't understand. And latency, same thing. I don't understand. There was no reason. Like it was the same binaries, the same Windows, no updates, nothing. Every 3 weeks, and then I filed the issue on the runtime because can't explain that. Okay, and so I will open the issue just to show you. Okay. And internally I was joking like it's based on the moon cycles. And I was jokingly saying it's based on the moon cycles because 3 weeks, it's a full moon, I don't know. And it was actually that, it was the moon.
Wasn't this featured on Y Combinator? I think I read.
Yes, they blogged about it, yeah. I was famous at the time, I made an issue. And it was always 20 cores, like, let's see the number of cores that are used by the thread pool. And I was confused. And then someone, and this is on other, and this was on other Linux machines. So it was not a machine because I used 4 different machines, physical hardware, no updates, nothing, same thing, okay? Like ARM machines, AMD machines, all the things I don't understand. Hill climbing. And then someone, like the day after, is like, when did they say that? He say, that's weird, it's like exactly like 49.7 days. And this is the time it takes for get tick count to reset to 0. And he's like, and if I do the calculation, that will be like January 14, February 7. And I'm like, yes, exactly the dates I have. How do you know? Yeah, because actually, if you look at the tick counts, it's an integer, an int 32. And on Linux, this int32 is wall clock based, meaning if you restart, the same number will be kept. It's based on the clock, not on how long the computer was started. It doesn't start at 0. It starts based on the time it is today. Okay, so even if you restart the machines on Linux, the number will keep increasing until it reaches overflow and starts back at minus or 0. Okay, I don't know if it was a inside or side, but it restarts because the number is too big. And the code of the thread pool was using this number to calculate the number of cores to use, because it just expected it to increase. Like it said, okay, in the last second, if we had like that many requests, let's increase the number of threads. That's the goal of the thread pool hill climbing. But the issue is that when it was going from 2 billion to 0, it was like a negative number. So it said, oh no, you need to decrease the number of threads. So instead of increasing by 20, it was decreasing for this amount of time because it was negative at that time, okay? And the developer who used this thing didn't think it could go down, like return to 0, so it was a negative number. And that was the issue. So just by assuming that it's weird that 49.7 days is exactly the number of ticks you need to fit into an integer, that fixed it. And I'm like, yeah, and he found the code that was doing that, and the fix was easy. Use the get ticks count 64, the long version of the thing, which was new in .NET, I don't know, 2 or 3, and that fixed it. So it's amazing to be able to find these bugs just by looking at the perf over time. Okay. Magic of continuous benchmarking. So benchmarking infrastructure in ASP.NET. So the charts you saw are available online. There is the link I just clicked. It's on the thread. It's on the AKMS ASP.NET benchmarks. So everything I showed you here, the charts, we have them. We run them every day for different apps, including Orchard. We measure the request per second, the latency, the time to first request, startup, all these things on different machines, different OSs, different pages. Like we look at MVC, Signalar. We look at different benchmarks, gRPC performance, build times, like how it takes to build an MVC project, Blazor project. Is the HTTP client faster or slower? How is the GC doing? How is .NET doing when you have containers, like micro containers, like milli-cores, 4 cores, 1 core, slow memory, and so on. Okay, we look at all these things, and there are charts for every of these kinds of things. Proxies. If you don't know what a proxy is and which one is the fastest, then it's not YARP, it's Nginx. Then HA proxy, then YARP. And Envoy, which is in Go, is also slower, if you know Envoy. And that's it for these benchmarks. The tools we use, and you should use, for load generation. Load generation is sending requests to a website. And the tools will be different in the kinds of requests they can send, how fast they can send it, what stats they give you back, where they run on, and are they scriptable or not? Because maybe you just want to send GET requests and you don't care about the result. Maybe you care about the result because you want the next request to depend on the previous result, like when you do authentication flows. Maybe you want the tool to be able to scale the number of virtual users and tell you when it goes down, or to do cycles. So all these tools do different things. The main ones I will recommend by experience. Don't try to use any other tool, because this tool will provide all the features you want. They're the fastest. The other ones are either slower, less full of features, and these ones are the best. Bombardier, but it's a Canadian word, so I will say it in French. Bombardier is the most versatile one. So it does the most things. It's the easiest thing to do. It's fast enough for all your web apps. It's portable, so there are binaries for Windows, Linux, ARM, all the things you want. And it's made in Go, so it's quite fast. K6 is one of the slowest, but it's the most configurable, and it works everywhere because it's made in Node.js. You can do all the scenarios you want, complex scenarios like hit this page, get the login, get back the authentication token, send it to the other request, start 10 users, increase by 10 users every second, all the things you want to do, it's K6. But it's slower, so if you want to measure your peak performance, don't use that, use Bombardier. Or use WRK. WRK is the fastest one. So if you have a web app that is super fast and you want to check you want to have the minimal impact on your CPU from your load generator, use WRK. This is the fastest one. And when I say fastest, it's like 10 times faster than Bombardier or K6. when I see people doing benchmarks and saying, oh, look, this web app is super fast, I use K6 to show it super fast. Dude, K6 is the bottleneck. Your client can't even send requests as fast as your server can do. Or look, these two web frameworks are as fast as the same, like C++ and PHP. No, it's just your load generation that is too slow to push the limits of one of the other. If you want to be sure, use WRK. WRK2 is the same as WRK, but optimized for latency measurements, because it will give you all the latency you want. If you just care about latency at a specific rate, use WRK2. It's a fork of WRK. Tracing. So when you have load generation to boost your app, you need to get measurements from your app. So you can use Purview, which is a Windows-only app. Super complex. Okay, you need a PhD just to click on the first button. There are videos online, but it's still hard. But you get also native code traces, not just managed code. So if there is some C++ code in .NET, you will also see the traces from that. Or if you have libraries from that. But usually you don't need, so you can use .NET Trace. To do that, which is a .NET tool. I will show you. I won't have time, I'm sure. Visual Studio.NET, so next year or this afternoon. And then, how do we make Orchard faster? How many minutes do I have left? I have 10-15 minutes.
No,
You have half an hour.
I have half an hour?
Half an hour including the Q&A.
Awesome. Seriously? Boy.
Well, it's early Christmas.
So maybe it's not this afternoon after all. If I stop saying nothing. Okay, how do we make Orchard faster? Okay, because Orchard is not as fast as we want, right? It's never as fast as it can always be faster. Does anyone have perf issues with Orchard? Core.
Yeah, okay.
It's fast, right? Who has used Orchard 1 and Orchard Core? Who thinks Orchard Core is much faster than Orchard? Everyone, okay? Who thinks Orchard Core could be faster? And then should be faster? No, awesome. Yeah, only Benedict thinks it should be faster. Everyone is like, it's so fast. And I agree, actually. And I will show you, it should be faster. If we can, let's do it. Okay. So this is a blog in Orchard Core. You recognize it? We've seen that many times. If you don't recognize it, I don't know. This is Orchard 1, the blog recipe. Same thing. And I went on a journey to try to see Orchard 1 versus. I've done that like 10 times per year for the last 10 years, but it's still interesting to because I have a jellyfish memory, so I don't remember. Orchard 1. So it's a blog. It has 0 blog post. I was surprised that the default recipe in Orchard 1 doesn't have a blog post. Maybe I'm wrong, but there is nothing in the recent blog post archive. So this is a widget, okay? A widget on the right, layers. There is a menu, just one item. There is a blog and no blog post. There is title. So technically, it's the same as this thing. A blog which has one title. A blog which has one post with title and everything. It has a taxonomy with 4 tags, 4 terms. So there is a taxonomy, there is 4 terms. This is not in Orchard 1. There is a widget with static HTML, but it's still a layer to evaluate. There is a menu. So this is equivalent. I will say this is equivalent. This is a fair comparison. And they are both, Orchard 1 is running on .NET Framework and Orchard Core is running on .NET Core. But technically it's the same thing. So let's see. So this is the screen, 2 screenshots. Orchard 1 on the dev branch and Orchard Core on the main branch. So this is a fair comparison on the .NET Framework, .NET Core 8 and the .NET Framework here. And I used Bombardier. So this is the result of the Bombardier tool that I run locally on my local machine. You should not do benchmarking on your local machine, but I can because you can see a big difference, so that will be valid. I could reproduce numbers. So here, request per second says 262.5. So 260 requests per second at peak load. So I used a minute, you see, it was 10 seconds of running, and I did multiple times to warm up the machine, so the caches are there and everything, and using 30 connections. So I have 30 open connections to the website. And Bombardier is like, every time one connection gets the response, sends a new request, and counts how many responses you get per second. So 260 requests per second for Orchard 1, and the same load, 4,200 on Orchard Core for the same thing. Okay, default recipe, just start and start. So it's 21 times faster. Good math?
17, 18, but yeah.
What?
17, 18 times. Okay.
Oh, because 2, 6. Oh, yeah, 2, 2. So how many?
17.
So 42 divided by 2.6?
17.
17 times faster than what? 17. Not twice as fast, okay? But 17. Even already twice as fast would be amazing. Like if I tell you, hey, tomorrow you have your salary increased by 2. You're like, what? No, 17, okay? Your salary is increased by 17. Imagine that. You're rich. That's what Orchard Core is to Orchard One. Okay? Super rich. Like Las Vegas rich. Like you buy the Eiffel Tower in Las Vegas with that. That's what Orchard Core is. And this is the RPS. And the latency, the average latency from 42 milliseconds, which is good, but not nothing, to 6 milliseconds. This is local, okay? There is no network, but just rendering 6 milliseconds. And again, it's correlated because when you have the peak performance, the request per second is correlated to the latency, but still. And the max at 99 percentile is 1 second. So the slowest request took 1 second on Orchard One and took 24 milliseconds on Orchard Core. So everything is better on Orchard Core, just the default thing. And we have 1 blog post, we have 4 taxonomies, so it's maybe more requests. Okay, that's good. And then I compared, we have a branch that works on .NET 9, which is in RC1 since Tuesday, and I ran Orchard Core on .NET 9 and .NET 8. So on the right I didn't change because it was .NET 8, the main branch, and I ran it on .NET 9, and if I look, it's still 4 because I didn't run it again, 4200 on .NET 8 and 5800 on .NET 9, and it's also faster in terms of latency. And this is a trend we see with every .NET release, because every .NET release, the runtime team, the SPNet team, but mostly the runtime team, the SPNet team, they are lazy as what you can think of, and well, lazy no. There isn't much we can do in SPNet. It's so light already that is very hard to do improvements. It's just the other layer of framework. And the runtime, however, is doing amazing improvements in the JIT, in the libraries, in the code generation. So this is why we get better just by updating the .NET Core, okay? So it will be better next month, during next release when you use the .NET Core 9. Good? So domain of interest in Orchard Core. Where can we look at to improve performance? Database access performance is usually the main issue. One of the main one, like 50% of performance is spent in database, because that's what is costly. Networking, finding data, fetching, creating data, allocating, deallocating, that's the database access. Okay. So in Orchard One, it was a big issue. That's probably why it's much lower than Orchard Core, because when we wanted to display one blog post, we had to do a query over 5, 6, 7 different tables, because we separated all the data in different things. It's nice, but it's bad for perf, very bad for perf. In Orchard Core, when you want a blog post, you download one JSON document. So in terms of database, it's super fast. There is more work to do on the server side, but apparently it's faster than anything you can ask the database to do. Allocations and garbage collections, because when you allocate, it takes some time to ask the OS to get some memory, but it also takes some time to understand that we need to release and release the memory. It's okay, I'm fine. So allocations is a big deal for a web app because it will add latency. When the garbage collector collects, it stops everything and say, hey, stop, let me collect everything because I need to be sure that nothing moves, I need to clean, start again, okay? So that's why garbage collection matters, and that's why allocations matter, because we don't want to spend the time on allocations and spend the time releasing the collections. Rendering. So rendering takes time. Like we need to mangle data, to organize data, to generate strings, to generate templates. That's also impacting allocations and garbage collections. And rendering means shape rendering, templating, widgets, layers. Layers is evaluating conditions on every display. Templating means evaluating some code, generating strings. Shape means events everywhere, doing crap that we don't need to, and lots of things. And then there are mitigations for that. Like it's fine to live with those issues, because we have some indications. Example, caching of UI and data. We can cache at the UI layer because it's the easiest thing to do. Like, oh, we have a menu. Instead of rendering the same menu again and again and again, let's keep that in memory, like we did yesterday with the shape display event, and just render the same thing until something in the menu changes, and then refresh the cache. That's the easiest thing you can do. We can also decouple the websites, use decoupled websites to remove the shapes and theming, because shapes and theming allocates a lot and takes a lot of memory, a lot of process. So if we don't use shapes, if you don't use theming, and you just use your Razor pages, then it will be faster. Or go headless altogether and do everything on the client side and call for APIs. And it's the less things we can do on a server, meaning the server will have less things to do, will be faster, and handle more requests. These are just mitigations. So caching, does it matter? Yes. Today we do caching by default in the menu. So when I say Orchard 1 and Orchard Core were equivalent, almost right and wrong, because actually on Orchard Core the menu is cached. So this is a little piece of thing that we don't have to render every time, and also query in database every time. So this is something we get. So the menu is cached by default in Orchard Core, and that's the only thing which is cached by default, the menu. And probably because we saw that it was safe to cache it, and because it had a significant impact on performance. The menu is cached by default. Let's disable it to see how it works. What can we cache also? We could cache the content items. Today we don't cache anything. So whenever we render a page, we load the content item from the database again and again and again. We could say, hey, instead of reloading the database content item, let's reuse it from memory. Maybe we'll save a database call. And we could also pay, so when I use the menu as an example, it's because it's caching the UI. This is caching the data, okay, not the UI. And we could do both. We could do caching content items one by queries, or we could also cache the UI, fine. And then you can also cache at the page level. So using, for instance, output caching, so the full thing. And in Orchard 1, you could not deploy a site without enabling output caching because it made it usable, at least on the front end, okay? So let's look at it. 20 minutes, give or take, right? So, oh no, you can't see what I type. I try to be clever. I won't say it's because of you, Victoria, because I know it's not because of you. You said it was nice, but we didn't think about that. Let's try this one. No. Why don't we go back to the standard one? This one maybe. Okay, this one. Can you see? Okay. So CD Orchard Core. Can I have a piece of paper? Oh, that. So Orchard Core and git status. I'm on the Sébastien Ros/net 90 branch because it's the 90 branch, and let's see if that builds. It will build. I will just build. Stop everything. I will just build the -- framework 80. Actually, I want to do a code change. So what I will do is run it. Shapes, who cares about shapes? Let's run it. I know who cares about shapes. Is it running? So what I want to show you is the perf of Orchard Core when we have the different layers of cache enabled, okay? And so first I will run it without any change, and I will show you how to do a load generation and see the results probably live. Then I will disable the cache in the menu, for the menu, just to see the impact of disabling the menu cache. And then I will go to the highest level we can do, and this is enabling the output caching. And see what's happening if the server does nothing but render a cached page like Orchard 1 was doing. And just do it in, because I'm doing it in the night, I don't need the 9.0 branch, but that will work. Okay, it's running. I have the website here. This is the beautiful blog. Okay, and I will run a load generation. So here, and I have the tool bombardier.exe. If you look for Bombardier GitHub, you will find a GitHub repository. In the release, you will find the binaries. You copy it locally, and you can do something like that. So here I will do, let's take what the arguments are here. Duration, I will do 10 seconds. I will start 30 connections. I want to see all the latencies, and the endpoint I will query is the about page, which is smaller than a blog post, so it's nice. It's easier to find the perf characteristics in this case. So I run that, and it will run for 10 seconds. The first run will be slow because the caching will happen, and also the jitting will happen. So .NET will see that the methods which are used more and more and say, oh, this method we can JIT it and JIT it better. So let's improve the code of that, and so on. And then the code will get faster as we do some queries. So after 2 runs, we will assume that after 20 seconds of high loads, like millions of requests, then the code is finalized and won't budge, and it will be the fastest we can get. So in this case, for the about page, it's not 4,000 requests per second, it's 10,000 requests per second. Okay, this is a simple page. Still with the widgets, with the layer, with the menu, but instead of loading a blog and the blog post and the taxonomies, we load a single page. Okay, an article, like body, title body, that's it. So 10,000 requests per second with 3 milliseconds latency, so super fast. So did I say I wanted to disable the menu cache, which is in the template itself, in the theme, the blog theme, in the layout, in Liquid. Here we have the menu shape that is rendered. And so this, I want to emphasize that what we are doing here is a Liquid tag that says create a menu shape, a string menu, like the string car from yesterday. Create a new shape of type menu. That's all I ask. A new shape of type menu. No data, nothing. So that relates to your question yesterday. Can we load the data dynamically? Okay. This shape I'm creating here is completely empty. It's just a shape type menu. It has no properties at all. And the shape tag here will render it. And I give it some properties to the shape tag that will change the shape metadata. So this thing here will actually say, so this shape will actually say load the content item called main menu. So it will still load the content item for that, but not all the menu items for that. And the cache ID is a property that enables the cache property on the shape metadata. And in Orchard, the dynamic cache module will do the same thing as we did yesterday when we cached the whole thing. But this one will be more clever. It will just cache specific shapes with a cache ID and organize them so they don't collide. And they will release the cache after 5 seconds. And we can also force all these things to be released if we say, oh, by the way, if anything like this is changed, please remove all the items. Okay, this is invalidation. So this is much more clever than what we did, but this is a feature in Orchard Core already. So I will disable the caching, and to do that, I will just remove all the cache properties. Like this. And to be sure it's working, and I'm taking a new template, I will add test here. I save it, and is it magic? There is no magic today. We run it again. It should be quick because nothing else than the template has changed, so it should detect it. That's why I want to run it from Visual Studio. It should have restarted. Yeah, that's the date of right now. If I F5 this page and go to the About page, now the menu should have been there. So I don't see the test thing, so I don't have the... If you have something to say, be louder because I won't hear you. And I'm okay with you saying something if you think I made a mistake. layout, the block theme, Control C, Control B, I rebuild explicitly this module, the theme, no errors, output build, worked, Control F5. Close that and close that. Check the source. What do you mean?
Check test in the source. HTML source.
You think it's there? I was expecting it.
It's given by the navigation.
Thank you. 1.4 Antoine. 0 everyone else. Losers. Okay, so this works. I don't have a menu cached anymore, okay, because it took my change into account. I don't know how to test it, but trust me. There is cache debugging if we want to enable, but we don't care. And I will do the same load again, okay? 2 times. Should it be faster or slower?
Slower.
If it is bad code, yes, but it is good code.
Faster.
Faster? No, if this is bad code, yes, it could now. Yeah, so yeah, it should, but it should be slower if the cache is bad code. Well, it's slower, okay? So the cache is good code because now without the cache we are at 2.5 instead of 10,000. Just for the menu, this little thing, link, home page, about page, just that. But it's one database request more. Instead of 2, we have 3, or instead of 1, we have 2. So it could be very important, okay? And allocations and everything. So just caching this thing is now actually 2.5. Oh, wait, it's the first run. Wait, no. It will be slower, but not that slower. This is just 10 times faster than Orchard 1, so no, it has to be 17 at least.
Or 16 actually. But it's better because it's...
Look, 5 now, okay? Right, once more. $5.5, okay? That's with the menu cache disabled. So that's very important. I don't care about adding it because now I will go into the web app and I will enable output caching. Output caching is a feature that was created in ASP.NET 7 by yours truly here present. Okay, output caching in ASP.NET Core. We did that in Orchard 1. Chris and Daniel and Sipke, not just Chris and Daniel, maybe not Sipke. Sipke also. Chris and Daniel did it in Orchard 1 better. Okay, they did a session in New York about that, and I made it even better in ASP.NET, so we don't have to do it in Orchard Core. So to do that, it's available in the ASP.NET framework actually, so we just need to go there and add the service. So I can say builder.services.add output cache. So the service is added. I will need to define a default policy because by default it's not caching anything. We could go on every endpoint and say enable the cache for that, but I can also say enable it for 3 minutes. Oh, I just need 1. I could just enable it for everything. And here I will say right after static files and before Orchard Core, I don't want to cache the static files. I will add the middleware .use Orchard Core. No, not use output cache. Okay, and what I need here is to build the policy. So I do the extensions that takes an options, and then I say options dot add base policy for all the things, and I say policy dot no cache, nope, expire, and I say time span dot from minutes 1. Close it. I'm lost so many closing. I think that's good. Close it. Here this should work. Base policy expire, and is there a dot cache? Yeah, there is a cache to be sure. It's probably the default, but I know we had to add that. So running it again, Control F5, release mode. How many lines of code? Some will say 1. Some will say it should be 10 lines already because you need to go back at the new line every time. But I will say 1. Plus 1, 2. It's in node 6 or 7, so it's in 8, and we today take 8 by default, so this should be a default option. But okay, so is it working? Page here, it's working here, and I don't know if it's cached. There might be a way, but we'll see. I don't know if it's cached. What is the impact of my change? Let's run a benchmark. I know what I wanted to show you on .NET 9. Sorry. And no way. It's so fast that even the 50th percentile is under 1 microsecond. Okay? And it's 88,000 requests per second. The slowest page was 1 millisecond. And this was the first run. Okay? Because the first page had to be rendered completely before being cached. And here, everything will vary by query string by default, because that's the default. If you change the query string, it will vary by, which means you won't leak secrets or whatever. It won't be activated on authenticated pages. It will be different values if you have a different query string. You can set which query string you don't want to vary by. So more than 1,000 requests per second, less than 1 millisecond for any request. Okay, that's the cost of the server. So 2 lines of code. What are you waiting for? But the issue, and that was my first comment, is Orchard Core fast enough? Yes, because in Orchard 1, we had to enable the output cache. In Orchard Core, it's so fast, nobody even cares about having an output cache module. Look, we've been talking about that for years. Nobody cares. Nobody wants it. Nobody needs it. So why? We can, but we don't need to. So can just be issues. Questions? Time.
Yeah, about the output caching, it's when someone's logged in.
It's not cached. So by default, the output cache middleware in ASP.NET, the default policy says if the user is authenticated in any way, caching is not enabled. So if I log in now, if I go in the admin, the cache is not active. Okay? And these policies, the default policy can be completely configured. You could say, I want caching on authentication. You can say that with your output cache. You just have to build your own policy.
So there's no gotchas about that when you just enable it like this?
No.
Awesome. So why not do it?
Because you don't need to in Orchard Core, and nobody feels the need to do that. So that's why we don't have it. But yes, please. I'm sure tomorrow we'll have 10 PR to do the same thing because you don't collaborate. But that's good, right? We'll close all of these PR, and Zoltan will be like, oh, we have to close PR. Yes, we have sometimes too because they're useless. But no. But that's a good thing to have useless PRs in this case, right? So.
Yeah. What version is this supported on?
6, 7, 8, 9, 10, and so. Today Orchard Core builds on 8 minimum, and it was shipped in 7 at least. Which means, yes, it's available today. It's been available for a year at least. I've shown that last year during a meeting. Hey, look, someone should do a module.
Okay,
but then a module means there are more things to do with a module. There is that thing, it could be enabled, and that works, like simple module, but you will have options like how long do you want the caching, or by section, like I want my blog to not be cached, I want my articles to be cached, and I want them to be cached for 1 minute, but I want them to vary by paging or not. You see these things. Or UTM tracker, don't vary the cache by UTM tracker. So we return the same value even if it's a different UTM tracker. All these things have to be configurable. By code you can do that, but if you do a module, you will need to be able to expose this configuration.
Does it help with warm-up?
No, it doesn't help with warm-up because the first page needs to be rendered completely.
Oh, yeah.
There could be, in Orchard 1 we have a feature which is we can serialize the cache on disk such that the next restart, if there is a cache, we will serve the cached version while we warm up the website. And when it's available, we'll serve the real site. It's a warm-up feature.
What would be the warm-up fix or kind of how to increase, how to have lower warm-up times?
By changing the middleware to not serve Orchard Core but serve a cached instance, even if it's not cached in memory but cached on disk, and then serve in parallel. So, yeah. So.
Okay. Cool. Yes.
There is also a response compression feature.
Yep.
Is it faster?
So response compression will make things slower on the server side, but compress the HTML or the static files. And this is a different middleware. that has been added at the same time as the output cache by a contributor on the ASP.NET team, on the ASP.NET repository, sorry. And the response compression, you can say, compress in broadly, but this is not, this is opt-in from the client side. If the client sends an accept broadly, then the server with this middleware will be able to compress the thing. There is not a middleware that says always compress, no, because the client has to say I accept that. And then it will work with that because it will cache the compressed thing. If you know it's on, so depending on where you put the middleware, if it's after the output cache, it will cache the compressed one, but you don't need to do that. Just so there is a response compression also. Middleware.
So if you use Azure as your hosting provider, what is there impact to your costs? Will it bring your cost up because of performance?
The caching,
demand your memory or
so the caching will be making things faster, so less CPU, so you can reduce your CPU size maybe. But by default it's cached in memory. But there is an implementation in ASP.NET for Redis. So you could cache, you have to cache in Redis. It will be a little bit slower because it has to do a network request every time, but there is no memory taken. It's just a Redis instance that you have to pay for, but you have to pay for the Redis instance. So you can limit the amount of memory that it takes and the size of the output cache pages it will store also, and then so to limit the memory usage. But it should never be an issue, even on big sites.
I noticed the liquid tag for the menu had a relatively short cache expiry and also a tag. Where I assume the tags is to invalidate it when the content item itself changes.
Yes.
Why does it have the short expiry if it expires?
Safety net, just in case. So for this one, it's probably just a safety net, because in case we don't catch a change, at least we can refresh. And it's once every 5 seconds, just one content item, one request out of 1,000 in case it matters, because it matters only if you have a lot. So it's cheap. It's a cheap change. However, we might also want the two of them for memory limitations. So in case we just use content eviction by change, and in case there is no change, everything will be cached after a while. So it's always good to always have an expiry, just to be sure that things get out of memory if they don't need to be in memory. Okay, it's like a sliding expiration. Otherwise, they will remain all the time in memory. So every cached entry should have an eviction.
I might be getting confused here, but doesn't the default implementation of them in-memory cache manage the memory?
It manages, but by default, you don't set any expiration, and it won't expire. It's supposed to be garbage collection triggered also. The iMemory cache, it's supposed to release it, but it might not release it. So maybe I think it's good to have to evict things, because even if it's garbage collected triggered, the memory cache, then maybe you have a lot of memory on the machine, and it will take 2 gigabytes of memory. But why do we use the 2 gigabytes of memory if we don't have to? Because this menu item is never used. Like, it's been added like 10 years ago. My site is up. Why is it still memory? It should get evicted. Okay. So sliding expiration for that is nice, because as long as it's used, it's in memory for some time.
Oh, it was a sliding expiration.
I don't know for this one, but at least you should have a sliding expiration.
Yeah.
Okay. And worse, the second level is at least also an absolute expiration, just to be sure something is getting out.
Okay, cool.
When we had design meeting for the memory cache or the caching, I was even suggesting we should have a default value in the default expiration, such that if someone doesn't say anything, we would add an expiration. Just for or then you be explicit about, no, this thing should be in memory all the time. There are things that you know will be used and have to be all the time in memory. Okay, even if it's in 10 years, I want it in memory because it's too expensive to load it, so I want it in memory. So these things, but you have to be explicit about that. That's my opinion. That's not the default in the output cache. Good. I have so many more things to show you.
Yeah.
But I think we have a good stuff. Thank you.
You need another session or not?
Yeah. Tomorrow I'm there, so let's go.
Okay, thank you very much for your session.